This problem says an object is dropped from a height of 87 feet. So that means that the initial point up here, or the top height would be 87. Its height above ground in feet t seconds later is given by the equation s of t is equal to negative 16 t squared plus 87. The first question asks, at what time does the object hit the ground? Enter as a decimal number. So the object would hit the ground when the height above the ground equals 0. So to relate the height above the ground equaling 0, that would be the function would equal 0. So let's plug in 0 is equal to negative 16t squared plus 87. And we're looking for the time that it hits the ground. So we're solving for t. Let's move the negative term to the other side to make it positive. 16t squared equals 87. And then to finish solving for t, we can divide both sides by 16. 87 divided by 16 is 5.4375. So t squared is equal to 5.4375. From here, we can square root both sides to get rid of the square. And that will give us, technically it would be t is equal to plus or minus a number. But we can talk about that in a second. So when I take the square root, I get 2.33184476, and it continues. So because we know that time only moves forward, we're going to ignore the negative option. So we're just going to take the positive decimal and enter it into that place there. So that would be the first answer. If you need more decimal places, check out what you get in your calculator, because it doesn't say how to round it. Part B, so this was part A. Part B says, what is the instantaneous velocity of the object as it hits the ground? We're looking for that in feet per second. So the instantaneous velocity, when we're given the height, the velocity would be the derivative. And to find the instantaneous velocity would be to find the derivative and plug in the time when it hits the ground, which we just found in part A. So taking the derivative, we get s prime of t is equal to, we use the power rule, so 2 times negative 16 is negative 32. T to the power of 2 minus 1 is just a 1. And then the 87, the constant, would go to 0 when we take the derivative. So this would be our derivative, and we need to plug in our number that we got from part A. So s prime of this number is equal to negative 32 times that number. That was really bad handwriting, sorry. And I kept that number in my calculator, so I'll just multiply it by 32, or negative 32 to be specific. And that gives me negative 74.61903, and it continues. That would be in a unit of feet per second because s is in feet and t is in seconds. So that would be part B. For part C, to find the average velocity as it is falling, that would be like drawing a line, a straight line. I know this isn't straight, but if we drew a straight line and found the slope of that line, that would be the average velocity. So let's use the formula for slope. That slope is equal to y2 minus y1 over x2 minus x1. And the second y value, we haven't actually found what that would be yet. But actually, let me think about an easier way to do this. Would be the average velocity. We're starting with, because we know that the object is dropped at this original point, the initial velocity here would be 0. And the velocity here we found to be the negative 74.619 and continuing. So to find the average velocity, we can just average those two numbers. So let me go back and just do this as an average. So to find an average, we add up the two numbers and divide it by 2. But our first number is 0, so it would just be 0 plus negative 74.61903, and then divide it by 2. So that gives me negative 37.3095, and continuing on. So again, I'm just taking the repeating decimal because it doesn't say how to round. So I hope this video step-by-step solution was helpful for you. If you have any questions, feel free to leave them in the comments, or a homework problem that you'd like to see a video on. Feel free to leave those in the comments as well, and I can make you a video as I have time. Thanks for watching.